Hi class, and welcome to our first video lesson on our notes for 7.3. What we're doing in this lesson is we're solving equations using quadratic techniques. So all of these are going to be polynomial functions, so polynomial meaning many terms, and we're going to solve them. And let's talk about what solve means. Solve means isolate the variable, or get x, oftentimes it's x. Let's get x all by itself. So with linear equations, it's quite simple. If we have 3x equals 9, obviously we divide by 3. When we have quadratic, or when we have polynomial, in this lesson, we're going to solve them using quadratic techniques. Most oftentimes, that means factoring, but there is going to be times in this lesson where we can solve using other ways, which another one would be using the quadratic formula. That's what we're going to do. We're going to get x all by itself by factoring or by using the quadratic formula. So for this first one, our degree here, class, always tells us how many answers we're going to have. How many zeros are there, or how many solutions are there? There's going to be 4. So immediately, you know that you have to give me 4 answers. For number 2, you have to give me 5 answers. For number 3, you have to give me 5 answers. So whatever your degree is, hopefully that's a nice quick check for you. That's how many answers you should have. So for this first one, the first thing we always do when we factor is we take out a greatest common factor if possible. On this one, you could take out an x squared. So when that's the case, you have x squared left plus 7x plus 12. And now we know that this trinomial here can be factored. So you're going to have x squared with 2 different binomials. Those binomials are x times x and a positive 4 times a positive 3. And then we have 3x plus 4x when we do our outside term and our inside term to make that positive 7x. So here we have successfully factored it. Now we're going to set each of these factors and equal it to 0. So x squared is going to equal 0, x plus 4 is going to equal 0, and x plus 3 is going to equal 0. For this first one, when you square root both sides, you get x equals 0. And now class, because this is x squared, there's 2 answers involved in there. So what happens when we get 2 answers for an x? It is a double root. Our next one, subtract 4, obviously x equals a negative 4. And for our third one, subtract 3, x equals a negative 3. There are your 4 answers. At x equals 0, you have a double root. So there's 2 of them involved right here. And then you have x equals a negative 4 and x equals a negative 3. So let's take a look what this looks like on the graph. It crosses at a negative 4 right here. It crosses at a negative 3 right here. And it doesn't cross. Remember what a double root means. A double root means that it comes down and it just touches 0 before it hops back up again. So that's where that double root comes into play. It just touches it before it hops back up. I'll say this one time and then I won't say it any more times throughout the video. If you want to, you could always put these back into your original equation and check your answer. If you put a negative 3 back up here and here and here, you're going to get 0 equals 0. So the left side is going to equal the right side. You can do the same thing when you substitute in 4, negative 4, or when you substitute in 0. So every single one of these, you can check your work on them as well. Moving on to the next one. You should have 5 answers for this one. The first thing you're going to do, just like the last one, let's take out a greatest common factor being x cubed. What's left? X squared plus 11x plus 24. So as you can see for these ones, these are polynomials. Our degree is 5 here, so that's a lot of terms. However, we're solving them using quadratic techniques. This particular one, we're going to solve using factoring. So we have x cubed times 2 different binomials, x and x. If we have a positive 3 and a positive 8, that makes it positive 24, and your inside and outside terms, 8x plus 3x makes 11x. So there we have it factored. Once you have it factored, let's set all of these terms equal to 0. These two are quite simple. X equals a negative 8 and x equals a negative 3. For this one, if you were to cube root both sides, well, the cubed root of 0 is 0, so you would get x equals 0. And because there's a 3 right here, there's 3 zeros involved there. So not only is it a double root, but we call this a triple root. Let's see what this looks like on the graph. It's going to cross at a -8. It's going to cross at a -3. That's where this point, -1, 2, 3, 4, 5, 6, 7, 8, it crosses right here as well. And then it also crosses at a -3, which is this point right here. And then what I like to call this triple root is a little doohickey right here. This kind of slanting through 0 before it hops back up again. That's what a triple root looks like. So a double root is when it just hits it and then it hops back down again. A triple root is where it passes through, but it passes through kind of slowly, and then it hops back up again. So that's what that triple root looks like. So here we have 5 answers. 1, 2, 3, 4, and 5. Moving on to the next one, once again we should get 5 answers. Just like in the last one, you can factor out a greatest common factor of x cubed. And what's left? X squared minus 196. That equals 0. So whenever we see 2 terms, class, hopefully we think it might be the difference of 2 squares. And this case is that particular instance. We have x and x. The square root of 196 is 14. So if we have x plus 14 and x minus 14, there we have our x times x is x squared, minus 14x plus 14x is 0 x's, which is exactly what you see right here, and a positive 14 times a negative 14 is a negative 196. So hopefully that makes sense. I'm going to erase this mess because it just confuses us. So now we have 3 factors. Let's set each of them equal to 0. So x cubed equals 0, x plus 14 equals 0, and x minus 14 equals 0. Once again, just like on our last one, x equals 0 on this one, it's going to be a triple root. So you're going to see that doohickey thing go through 0 again. Here we have x equals a negative 14, and here x equals a positive 14. So on our graph, it's not going to show the negative 14 and the positive 14, but the negative 14 is somewhere way over here, and a positive 14 is somewhere over here. Our graph is going to go through those 2, and then it also goes through 0, which is right here, and it's a triple root right there, so it's going to kind of slant through it. So that's what we're looking at for that one. Moving on, number 4, why don't you guys pause the video, try this one on your own. Unpausing the video, it's similar to the last one with a couple major differences. You're going to first factor out a y, and now you're left with y to the 4th minus 144. This is also going to equal 0. So now just like we had in number 3, right here is the difference of 2 squares. Whenever you see 2 terms, think, I wonder if this is the difference of 2 squares. More often than not, it is. So this is going to be y squared and y squared, because that makes y to the 4th. And then the square root of 144 is a 12. So 1's going to be a negative 12, and 1 is going to be a positive 12. You can't factor these down anymore, so let's just set each of these factors equal to 0. So y equals 0. Y squared minus 12 equals 0. And y squared plus 12 equals 0. Now, class, we're going to solve each of these for y. So first one, piece of cake, y equals 0. We're going to add 12 here, and then take the square root of both sides. So this breaks down into 4 times 3. So y equals, the square root of 4 is 2, and then the square root of 3 has to stay underneath that radical. Remember, when you take the square root of something, you need both the positive and the negative. So it's plus and minus 2 square root 3. And then for our third one, y squared equals a negative 12. And then when you square root both sides, y equals plus and minus the square root of 12, a negative 12, which a negative 12 breaks down into 4 times 3 times a negative 1. If you forgot what all of these mean, let's refresh your memory. The square root of 4 is 2. The square root of a negative 1 is I. So you can bring out 2I, and then you're left with the square root of 3 underneath the radical. So y equals plus and minus 2I square root 3. So going back up to the top, you should have 5 answers. Y being 0 is 1. Plus 2 square root 3 is 2. Minus 2 square root 3 is 3. Plus 2I square root 3 is 4. Minus 2I square root 3 is 5. So there are your 5 roots. These two are imaginary, which means they do not cross the x-axis. So these 3 are the only ones that cross the x-axis. So at 0, 2 times the square root of 3, and a negative 2 square root of 3. Those are the ones that cross the x-axis. These are imaginary. They do not cross the x-axis. Moving on to number 5. You have to get a 0 over here on the right side. So let's subtract 13x squared. X to the 4th minus 13x squared plus 36. That equals 0. So now we see if we can take out a greatest common factor. Unfortunately, we cannot. So now we're just going to start factoring. Form 2 different binomials. We're going to have x squared and x squared. And now factors of 36 that get us a negative 13. 9 times 4 is 36. We need a negative 13 in the middle. So here we have, foiling back, x to the 4th. Minus 4x squared minus 9x squared gives us our negative 13x squared. And then our last term, a negative 9 times a negative 4. There's our positive 36. So we have successfully factored our trinomial. Now that we've done that, we see, can we factor any further? Whenever you see 2 terms, what should come to your brain? Hopefully the difference of 2 squares. This can be factored down into x minus 3 times x plus 3. This can be factored down into x minus 2 times x plus 2. So you can factor that down one further again. Now, each of these are factors that you set equal to 0. X minus 3 equals 0. X plus 3 equals 0. X minus 2 equals 0. X plus 2 equals 0. So what are our answers? X equals 3, there's 1 root. X equals negative 3, there's 2 roots. X equals positive 2, there's 3 roots. X equals a negative 2, there are 4 roots. Going back up top, our degree is 4. This works out perfectly. So our answers, it crosses at a negative 3, negative 2, a positive 2, and a positive 3. Hopefully the graphs are really starting to make a lot of sense after you solve the equation. So finding those zeros is a very valuable thing, class. That's why we're practicing it so often. And now, moving on to number 6. Number 6, we see if we can take out a greatest common factor, but we cannot. So let's just start factoring this. X squared and x squared. Factors of a negative 12 that get you a positive 1 is going to be a positive 4 and a negative 3. At this point, you see 2 terms, and what should you always think of when you see 2 terms? Hopefully you think of the difference of 2 squares. If that was your thought process, very good. However, it was useless in this case because it's not the difference of 2 squares. This one is the sum of 2 squares, which we have no formula for that. And this one is the difference. However, 3 is not a perfect square. So we're stuck as far as factoring is concerned. But we're not stuck as far as solving is concerned, which is nice. Once we get to here, we now say, well, x squared plus 4, that equals 0. That's a factor that we're going to set equal to 0. And x squared minus 3, that also equals 0. It's a factor that equals 0. So now let's solve for x. You're going to subtract 4 from both sides, and then square root. So this is the same thing as a positive 4 times a negative 1. So x equals, when you take the square root, you need the plus and the minus. The square root of 4 is 2, and the square root of a negative 1 is I. So there's 2 of your answers. They're imaginary roots. They do not cross the x-axis, but they are answers nonetheless, plus and minus 2i. The other 2 are found right here. X squared equals a positive 3 when you add 3 to both sides, and then you square root both sides. So x equals both the plus and the minus square root of 3. These are our 2 real roots, so those are the ones that are going to cross the x-axis. Add a positive square root 3, which is right here, and a negative square root 3, which is right there. I'm going to record another video lesson with the last 2 problems on there because they are a little bit different, that I just want to break up the lesson as far as similarities and differences are concerned. So be sure to let me know if you have any questions on that tomorrow so that you can have most success on your worksheet coming up.